Hello, everybody. So in this video, I'm going to be discussing two-mean hypothesis testing for independent samples when our population standard deviations are known. So let me go ahead and screen share and we'll get started here. Okay, so here's our first example we're going to do here. So a group of researchers believe the average number of calories high school students eat on a daily basis is different than the average number of calories college students eat on a daily basis. We have a sample of 50 high school students, sample mean 2,200, and 60 college students, sample mean 2,300, and we have the population standard deviations for both. Our significance level is 0.05, making the high school students sample 1 and the college students sample 2. So, for this type of hypothesis test, the null hypothesis is always that mu1 equals mu2. So remember, sample 1 is high school, sample 2 is college. So the mean of high school equals mean of college. That's always the null for this test. Mu1 equals mu2. And then the alternative is going to depend on the context of the question. So it said different than. So my alternative is going to be mu1 not equal to mu2. I just want to know if the mean of high school is different than the mean of college. So let's go to our Rguroo and put all this in here. So it's going to be analytics, analysis, mean inference, 1 and 2 population. I'm going to select my data set. Oh, there's no data set. Sorry, hold on. Okay, so never mind. I had to enter my information down here. So my label for my first sample was, I believe my first sample was high school. Yes, so high school calories we'll say. And then for sample 2, we'll use college calories. So high school calories and college calories. Now for high school, my sample mean was 2,300, sample size 60, population standard deviation 150. So 2,300, sample size 60, population standard deviation 150. And then for college, my sample size was, oops, I got that wrong. Hold on, that was college. There was 50 high school students, and the sample mean was 2,200. There we go. Okay. And then for college, 60 students, sample mean 2,300, population standard deviation 200. So 2,300, 60, and 200. And then now you go to population 1 minus 2, test of hypothesis, significance level was 0.05. And then so here, so they basically rewrote this. So they subtracted the mu2 on both sides, basically, which gets you mu1 minus mu2 not equal to 0. What you can basically remember here is, though, that you're going to put whatever the sign is of the alternative here, which is not equal to, and 0 always goes in this box. So like algebraically, basically they had mu1 equals mu2. So I'll just show this to you once so you get the idea. And then they subtracted mu2 on both sides. Sign. So then that gets you mu1 minus mu2 equals 0, which is where this comes from. But like I say, you can remember, just put the alternative sign here, and then, or this was a not equal to sign here. So you can put whatever the sign is the alternative here. Remember the exclamation point with the equal sign is not equal to, and then put 0 in the box. That's what you can remember. Okay, so now, and then we know our population standard deviation, so that means we check Z. If we didn't know, then we check T. Hit the eyeball. I get a p-value 0.0028. This is the test statistic if you were ever asked for that. So my p-value is definitely less than my significance level of 0.05, so that means I'm going to reject the null hypothesis. If we reject, that means we have sufficient evidence HA is true. So we have sufficient evidence to conclude that the mean number of calories high school students eat on a daily basis is not equal or different than the mean number of calories college students eat on a daily basis. So we have sufficient evidence that HA is true, writing HA basically in sentence form. All right, let's do another one here. So the leaders of a particular state believe the mean age of children in town A is higher than town B. Assume the leaders take a sample of 70 children from town A and determine the sample mean is 12.3. And they took a sample from town B of 70 and the sample mean is 12. And then we have our population standard deviations. Significance levels 0.01, town A sample 1, town B sample 2. So my null, like I said, is always mu1 equals mu2. And then I was told town A is higher than town B, so that means mu1, which represents town A, is greater than mu2, which represents town B. Let's go to our Rguroo and enter everything in. So I'm just going to go under here and edit what we had. So I'm just going to go to summary. Well, actually, you know what? I'll just open a new one. It's easier here. So analysis, mean inference, 1 and 2 population. So under label, you're going to put your variable names. So the first one was town A, age of children in years. Now, technically, you could put anything in these boxes to make it run, but you do have to put something. I always put the variable name, and I always include units just as we always want to with variable names also. And then the other one's town B. So for town A, my mean, 12.3, sample of 70, population standard deviation, 2.5. So sample size 70, 12.3, population standard deviation, 2.5. And then for sample number 2, it was also 70, mean 12, population standard deviation 3. So mean 12, population standard deviation 3, sample size 70. Go to population 1 minus 2. Go to test of hypothesis. My significance level is 0.01. And then this one's going to be greater than 0. Greater than was the sign of my alternative, and then you always put 0 in the box. And then a z statistic because we don't know we do know the population standard deviations. If you didn't know the population standard deviations, you would check t. Hit the eyeball. I get a p-value 0.2602, and this is the test statistic if they ever ask you for that. So that p-value is higher than my significance level of 0.01, so I'm going to be failing to reject the null. If I fail to reject, that means I don't have enough evidence that HA is true. So I don't have sufficient evidence to conclude that the mean age of children in town A is greater than the mean age of the children in town B. So once again, writing that alternative hypothesis in sentence form. I don't have sufficient evidence that that is true. All right, let's do one more of these and then we'll do some with data sets. So a realtor claims that the mean price of homes in neighborhood B is higher than A. And then we have all our information here. So we took a sample of 20 homes from A, sample mean 450,000, and 25 from B, sample mean 475,000. And then we have our population standard deviations, significance level 0.1. Neighborhood A is sample 1, neighborhood B is sample 2. So our null is always mu1 equals mu2. Now the alternative here, so I said neighborhood B is higher than neighborhood A. So that means mu1, which represents neighborhood A, is less than mu2, which represents neighborhood B. So the wording's a little tricky here. So let's go to our Rguroo and enter everything in. So I'm going to go to the analysis, mean inference, 1 and 2 population. In the label boxes down here, I'm going to enter the variable names of my 2 samples, which was, so the first sample was neighborhood A home price in dollars, and then my second variable is neighborhood B home price in dollars. And then my sample mean for neighborhood A, sample mean 450,000, 20 sample size, population standard deviation 30,000. So 450,000, sample size 20, population standard deviation was 30,000. Sample B, sample mean was 475,000, population standard deviation 40,000, sample of 25. And then population 1 minus 2, test of hypothesis, significance level 0.1. And then this one was less than for my alternative sign. And then you always put 0 in this box. And then check Z because you know the population standard deviations. If you didn't know the population standard deviations, you check T. Hit the eyeball. Get a p-value of 0.0083. So that p-value is less than my significance level of 0.1. So that means I'm going to be rejecting my null. If we reject, that means we have enough evidence that HA is true. So we have sufficient evidence to conclude that the mean price of homes in neighborhood A is less than the mean price of the homes in neighborhood B. You could also have said that neighborhood B is higher than neighborhood A if you prefer to use like the original wording of the problem. So we have sufficient evidence here that HA is true, written out in sentence form in the context of the question. All right, let's do some with data sets now. So researchers believe the average weight of dog breed B is lower than the average weight of dog breed A. And then we have population standard deviations for both and data sets here. Significance level 0.05, dog breed A is sample 1, dog breed B is sample 2. So my null is always mu1 equals mu2. My alternative, so I'm saying dog breed B is lower than dog breed A. So that means that A, which is mu1, is greater than mu2, which is dog breed B, since dog breed B is sample 2. So I said B is lower than A, so then I need to write my alternative here since A is sample 1, is A greater than B. So once again, be careful of the wording on that. So let's go to our Rguroo here. So first, let's download our data set off Blackboard. So this is going to be the 10.1.9 dog weights data set. And then I'm going to go to data, data import, import data set, choose the file from my downloads folder. And then remember, you want to select header in the first line if your first line has a title. All my data sets do. Just double check the ones on Newton. If it didn't for some reason, then you put no header, but they should. Hit upload. And then we have our data set in here. So I'm going to go to analysis, mean inference, 1 and 2 population, select my data set, and then select my variables, which is breed A and breed B. So now notice it populates everything down here for you. You just need to enter in your population standard deviations, which were 2 and 1.5. Oops. Go to population 1 minus 2, test the hypothesis. My significance level was 0.05. And then I said I'm going to put, so my alternative sign was greater than. Then remember, 0 always goes in this box. And then check Z statistic because you know the population standard deviations. If you didn't know the population standard deviations, you check T. Hit the eyeball. I get a p-value of 0.153. And remember, this is the test statistic if you ever ask for that. If you ever want to save one of these, you can also put a title here and hit Save As. So that p-value is higher than my significance level of 0.05. So that means I'm going to be failing to reject the null. If we fail to reject them, means we don't have enough evidence that HA is true. So we don't have sufficient evidence to conclude that the mean weight of dog breed A is greater than the mean weight of dog breed B. So we don't have sufficient evidence that HA is true, writing HA basically in sentence form in the context of the question. All right, let's do another example here. Police believe the mean speed adults drive on a particular highway slower than teens. And then we have the population standard deviations and the samples. Our significance level is 0.1. Adults is sample 1, teenagers is sample 2. So as always, our null is mu1 equals mu2. And then I said adults, which is sample 1, is less than teenagers, which is sample 2. So that's why our alternative here is less than. So let's go to our Rguroo and enter everything in. So let me go ahead and close all this out first. I'm going to right-click and delete the data set. All right, so then I'm going to download the driving speeds data set. And then I'm going to go to data import, import data set, choose the file here from my downloads folder. And then hit upload. Remember, just double check on Newton that you have a title in the first line. My data sets always do. All right. And then analysis, mean inference, 1 and 2 population. Select my data set. Select my 2 variables, which is adults and teenagers. And then population standard deviations, 3 and 3.5. Then population 1 minus 2, test of hypothesis. My significance level is 0.1. And then I have less than, and then you always put 0 in the box. And then Z statistic, because we know the population standard deviations. If you didn't know the population standard deviations, you would check T. Hit the eyeball. I get a p-value of 6.0272 e negative 5. So remember that means to move the decimal point 5 places to the left, which gets you this number here. So that's just this with the decimal point moved 5 places to the left. It's basically 0. It's less than the significance level of 0.1 for sure. So that means we're going to be rejecting. If we reject, that means we have enough evidence that HA is true. So we have sufficient evidence to conclude that the mean speed adults drive is less than the mean speed teenagers drive on the highway. So we have sufficient evidence that HA is true, with HA written in the context of the question. All right, one more example here. Researchers believe the mean commute time in state A is different than state B. Assume the commute times in state A are normally distributed with population standard deviation of 10.5. And then we also have the population standard deviation for state B. And then we have the two data sets. And then my significance level is 0.01. State A is sample 1. State B is sample 2. So my null is mu1 equals mu2. My alternative is, as always, my alternative is going to use not equal to because I said different than. So now let's go to Rguroo and enter it all in. So I'm going to go ahead and right-click and delete the data set here. Download the commute times data set off Blackboard. And then data import, import data set. Choose the file from my downloads folder. Just double check that you have a title on the first line. All my data sets do. Just double check the newtons. Hit upload. And then analysis, mean inference, 1 and 2 population. Select the data set and the variable. Now my population standard deviations here are 10.5 and 9. And then go to population 1 minus 2. Test of hypothesis. My significance level, 0.01. And then the sign of my alternative was not equal to, and you always put 0 here. And then check Z, because we know the population standard deviations. If you didn't, you would check T. Hit the eyeball. I get a p-value of 0.2204. This is the test statistic if they asked you for that. So that p-value is greater than my significance level of 0.01. So that means it's going to be failing to reject the null. And if we fail to reject, that means we don't have enough evidence that the HA is true. So we don't have sufficient evidence to conclude that the mean commute time in state A is different than the mean commute time in state B, the alternative written in context of the question in sentence form. And that is it. So that is two-mean hypothesis testing for independent samples when the population standard deviations are known. If you have any questions, please feel free to reach out.